Hi everybody, and welcome to the homework video for section 8 of chapter 3 where, yep, you guessed it, I get to do your homework. And here we have our homework set up. Here is Hawks, here is my calculator, and here is my OneNote in case I have any kind of drawing or stuff that I have to do. Let's first go ahead and go into Certify to see what we're dealing with. Then once again, this is where you do your homework. And you have count them, 4 whole problems to do. Okay, well, each problem has 2 steps, so basically there's 8 questions, and you're only allowed to miss 2 of them. So if you get 6 of the 8 done correctly, you're good to go. If you don't, you're going to have to start over again. Okay, so let's go back and over here, or go back to practice, and I'm going to do the exact same problems. And practice once again has the exact same problems, but they provide you with a little feedback. So, and what I'm going to do is I'm going to do 2 basically using our tables, and then I'm going to do 2 using our calculator. Okay, here a manager holds repair calls for 14 randomly sampled dryers. A sample mean of $88.34 and standard deviation of $19.22 are subsequently computed. This is a sample standard deviation. We want to determine a 90% confidence interval for the remaining repair costs of the dryers, and we can assume that the population is approximately normal. Okay, and the first thing we need to do is we need to find the critical value. Now, to find the critical value, we are going to want to go into our collection of tables. Since this is a sample standard deviation and we do not know the population standard deviation, we have to use a t-table. Okay, and we want to find the area in one tail, not the area in both tails. Okay, so now notice here that our confidence interval is 90%, so C is equal to 0.9. That means that the area in both tails, alpha, is going to be 1 minus C, which is going to be 0.1. Okay, and then alpha over 2, the area in one tail, is going to be equal to 0.05. And that means that we will be looking in this column right here. Notice also that we have 14 samples. So the degrees of freedom is going to be equal to 13. And that brings us to this number right here, 1.771. Now what you can do is you can come down here, click on that number, copy the selected value. Okay, it's been copied. You can close the table. And we can close the table by clicking the X here, and then we can go ahead and paste the value. Just go over there, right click, hit paste. Okay, that should be our answer. Go ahead and submit it, and there you are. Okay, now, the next part is to compute the 90% confidence interval. Now, to do that, we need to figure out what E is. E is going to be equal to our critical factor, which we just figured out before, all right, times our our sample standard deviation divided by the square root of n. Okay, from our previous step answer, we can see that E is 1.7, or that our critical value is 1.771. Our sample standard deviation is $19.22. And our total number of samples is 14. Okay, so going ahead and compute that, that's going to be 1.771 times 19.22 divided by the square root of 14. And that gives us a value of 9.0972. Okay, so that's what we have. If that's the case, then our lower endpoint is going to be our sample mean minus the error, which essentially is going to be $88.34, 88.34. Hang on. 88.34 minus this number right there. Hit enter, enter again, and that gives me 79.242, which is going to round to 2 decimal places to 79.24. Okay, and then the upper limit is going to be, what I can do is just highlight this, change the minus sign to a plus sign. Oh, didn't want to do that. Let's try that one more time. Highlight this, change the minus sign to a plus sign. There we go. Then hit enter, and for the upper limit, I get 97.437, which will round to 97.44. Okay, so my lower limit is going to be 79.24. My upper limit is going to be 97.44. And there you go, that happens to be correct. Moving on to the next problem. And the next problem, we have a student examines 8 seawater samples for nitrate concentration. So N is going to be equal to 8. The mean nitrate concentration for the sample data, that's going to be X bar, is 0.424, and the standard deviation, that's the sample standard deviation, is 0.0827. Okay, we want to assume a 90% confidence interval, or find a 90% confidence interval. So C is equal to 0.9. Okay, and we're going to assume that the population is approximately normal, which means that we can use t-distributions, and we need to find our critical factor. To do that, we need to figure out what alpha over 2 is. Alpha is equal to 1 minus 0.9, which is 0.1. And then alpha over 2 is going to be equal to 0.05. All right, now we need to figure out our degrees of freedom. Since N is 8, our degrees of freedom is going to be equal to 8 minus 1, or 7. So we go into our tables. We want to go to our t-table, 1 tail. We are looking for the column of 0.05, degrees of freedom 7, and that gives us 1.895. We can copy that value, close the table, paste it into here, and then submit our answer, and it happens to be correct. And just let me write that down. T alpha over 2 is 1.895. Okay, moving on to the next one. Now we need to figure out what our confidence interval, or what our confidence interval is, first by computing our error. Our error is going to be equal to T alpha over 2 times sigma, no, not sigma, S. S, our sample standard deviation, divided by the square root of N. That is going to be 1.895 times 0.0827 divided by the square root of 8. Okay, on our calculator, 1.895 times 0.0827 divided by the square root of 8. That gives us an error of 0.0554. So our lower limit is going to be X bar plus E. No, I'm sorry, minus E, my bad. Minus E. Okay, so that is going to be 0.424 minus this number right there. That gives me, we went to 3 decimal places, so that gives me 0.3685, which is going to round to 0.369. And then for our upper limit, is going to be x bar, our sample mean, plus e. In other words, we can just come up here. We can highlight this, change the minus to a plus, and we will get 4794, which will round to 0.47. Whoa, what happened there? Let's do it over here. Rounds to 0.479. Okay, so our lower limit should be 0.369. Our upper limit should be 0.479. And there we go. Okay, now at the next two problems I'm going to do using a calculator. So here we have a consumer affairs investigator records the repair cost of 4 randomly selected washers. So N is equal to 4. The sample mean turns out to be $52.63. So X bar equals $52.63, and the sample standard deviation, we're not implying propagation, that is sample, is $22.01. We want to determine the 80% confidence interval, so C is equal to 0.8 for the mean repair cost, and we want to assume that the population is approximately normal. Okay, now the first thing that we want to do is we want to compute the test statistic. To do that, we still need to figure out what alpha is. So if alpha over 2 is. So if C is 0.8, then alpha is 1 minus 0.8, which is 0.2. And then alpha over 2 is equal to 0.1. My degrees of freedom is going to be equal to my sample size minus 1 or 3. Now, to figure this out using our calculator, we need to go into distribution. So that'll be second VARS, and we are looking for the inverse T. We have an area, we have a degrees of freedom, we want to know what T is, so that's going to be 4. Okay, my area is going to be 0.1. My degrees of freedom is 3. And now we can just go ahead and paste and calculate this. And we get negative 1.6377. Now, in this particular case, we only want to take the absolute value. The critical factor is always a positive number. So we're going to ignore the minus sign, and we're going to have that T alpha over 2 is equal to 1.6377. We went to the 3 decimal places, so this is going to round to 1.638, and that should be our answer. Just to make sure, let's go into our tables. T-value, area in one tail. We have 3 degrees of freedom. We're looking at 0.1, 1.638. They get the exact same thing. Okay. Now for the next part, we actually want to use the T-interval test, so we can find that in STAT. Okay, we want to go over to tests, and we are looking for T-interval, which happens to be 8. Now for this one, we want to make sure that we're using statistics. Our sample mean happens to be 52.63. 52.63. Sample standard deviation is 22.01. 22.01. Number of samples is 4. Our C interval is 0.8. Go ahead and calculate. And we will have, and we want this to 3 decimal places. There's our 3. No, to 2 decimal places, my bad. So this is going to round to 34.61. This is our lower limit, and this is our upper limit, and since my 3rd decimal place is a 3, we're just going to use 70.65. And there you go. And then finally, we're going to do the exact same thing for this one. Now, in this particular case, we have a random sample of 27 fields. So N is equal to 27, gives a mean yield of 28.6 bushels per acre. So X bar is 28.6. And the sample standard deviation, S, is equal to 5.92. And we are looking for the 95% confidence interval, so C is equal to 0.95. First thing, test statistic. We need to figure out what alpha is. Alpha is going to be equal to 1 minus 0.95, which is 0.05. That means that alpha over 2 is going to be equal to 0.025. Degrees of freedom is going to be 27 minus 1, or 26. Okay, that means we want to go to our calculator. We want to go into distributions to inverse t, 4. Okay, and our area is going to be 0.025. Degrees of freedom is 26. Go ahead and paste that bad boy and calculator, and we get that T alpha over 2, our critical value, is going to be equal to 2.0555. Since my fifth decimal place is a 5, this is going to round to 2.056. Okay, and now for the last part. To find our confidence interval, we want to go into stat, test, number 8 for t interval. We want to use stats there. My sample mean is 28.6. Sample standard deviation is 5.92. Number of samples is 27. Confidence interval is 0.95. No, not that. 0.95. Okay, go ahead and calculate. And we get that our lower limit is going to be 26.26. Notice the third decimal place is an 8. Got to round up. And the upper limit is going to be 30.94. So lower endpoint, 26.26. Upper endpoint, 30.94. And there you go. And that is how you do your homework. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.